Hello, and welcome to another episode of Eon's Answers, where I am wearing my new football boots. Just arrived. Oh yes. You can feel free to tell me how awesome they are, because they are, in fact, awesome. And also I answer some science questions. Richard Feynman once said that if you thought science was certain, that's an error on your part. Might as well be the slogan of this show. Onwards! I don't think anyone really knows at this point. I'm sure they just make half of these things up as they go. String theory is an attempt to reconcile the two main theories of modern physics, general relativity and quantum mechanics. Now, general relativity, gravity in other words, works on large scales, us, planets, stars, black holes, whereas quantum mechanics works on the smaller things, atoms, particles. They should work together, but they don't, and string theory is an attempt to fix that. Basically what it says is that elementary particles like electrons and quarks aren't point-like we think that they are, but are actually one-dimensional strings wrapped up so tightly that we think that they're a point. It goes on to predict things like supersymmetry, extra dimensions, and could even be a theory of everything. It all looks good on paper, but the problem is that it's almost impossible with today's technology to test it experimentally. So really, we don't know what it is, if it's true. The wonders of special relativity. To you, firing the gun, the bullet will appear to move at its normal speed. Let's call that b, and that's approximately 500 kilometers an hour. That is because in your frame of reference, you are not moving and the bullet is travelling in front of you at its normal speed. However, to an observer who is at rest, you are travelling at a speed v, close to the speed of light. Now, when you fire the bullet, to the observer, the bullet is no longer going at the speed b. It's now going at a speed, let's call it b prime. And this speed b prime is equal to gamma times v plus b, where v is the speed that you're travelling at. And gamma is what's known as the Lorentz factor, and it's required when moving from one reference frame, yours, to another, the observer's. And it's given by this formula here. Basically, the closer to the speed of light that you get, the additional speed that the bullet appears to get is actually less. And thus it never actually surpasses the speed of light. The Wikipedia page on Lorentz transformations is great. Read it. It will really help understand that. Well, the universe was created about 4,000 years ago by a great, all-powerful, invisible deity who did it in 6 days and then had to rest for one. Yeah. The Big Bang Theory states that the universe started from an extremely hot, extremely dense state of energy, which may or may not have been a singularity. It expanded from that state, and as it expanded, it started to cool. Like when you spill your coffee on your desk and it cools really quickly and becomes really sticky. That kind of happened to me today. Eventually, after a second or two, it became cool enough that particles could actually start to form, and thus the universe that we know and love today came into existence.
He's a pale supernova with a bona fide attitude.
Okay, because neutrinos and antineutrinos are neutral electrostatically, they could actually be the same particle. However, there's not really any experimental evidence for that at the minute. Otherwise, they differ in something called helicity, which it's mathematically defined as the projection of spin in the direction of momentum. This basically has no real-world analogies. It's something that physicists made up to make maths make sense. But that is literally the only thing that they're different in. Antineutrinos are right-handed, and neutrinos are left-handed. Don't get this confused with neutrons and antineutrons, which are made of quarks and antiquarks, respectively, and thus differ in all sorts of ways. Alright, that's it for this week. Thanks for all your questions, guys. If you have any comments, any feedback on the show, post them in the comments below. Again, if you have any of your own questions that want answered, post them in the comments as well, and I'll try and answer them in an upcoming video. See you next time. Good. Push go.
Go, she's a sweating, not the mojo, can I reach her altitude?